Testing. Welcome back, class. Today we're going to be looking at section 8.3, and I'll be assigning this 8.3 this Friday, making it due next Wednesday, which I believe is April 8. So 8.3 assigned here today, Friday, due next Wednesday, April 8. This section is about radicals, one of those being a square root, as well as about fractional exponents. And we're putting those two together here today. This should be review for you. The square root, that again is a radical sign there. There's no number written out front, which implies it's a 2. It's not written there, but it stands for the square root. The square root of 25 is defined to be 5 because the reason 5 is the answer is because if I take 5 times 5 twice over, I end up with the number 25. So the square root means I multiply it 2 times. Cube root of 8 is 2 because cube root there is written, means this 2 multiplied times itself 3 times. 2 times 2 times 2 has to give you the argument 8. That would be an example of a cube root. The fourth root of 81 would be some number times itself 4 times. That ends up giving you the value 81. Some of these are a little more challenging. They're not automatic for everybody, but I tried to keep these as nice integers. The correct answer turns out to be 3, because 3 times 3 is 9, times 3 is 27, times 3 is 81. So the fourth root of 81 is equal to 3. But we would also like you to notice, and I could have done that up here with the 25 as well, I could have said the square root of 25 is a negative 5. The reason for that is a negative 5 multiplied times a negative 5 is also 25. The positive one is referred to as the principal root, and when in doubt, that's the one they're usually looking for. The fourth root of 81 could have been 3, but it also could have been a negative 3. Whenever we have an even root, fourth root, or square root, we technically can get 2 answers. The book will expect you to give the positive answer in those cases. As I mentioned earlier, square root of 49 equal to the positive root is the principal root. It's one the book will be expecting. If they want a negative specifically, they will put a negative out front. That negative comes along, giving you that negative 7. This is the one that's quite important for us though as well today, the square root of a negative number. We say it has no answer because if I would have had an answer, if I had taken it times itself, I would have to get a negative 49. Some people think, excuse me, this should be a negative 7. But if I put a negative 7 in here times itself, I get a positive 49. So a negative 7 is not going to be the answer there. There is no number if you take it exactly times itself, so that'll give you a negative 49. So that gives us a kind of a general rule. The square root of a negative number is going to have no solution. Square root of a negative 16, no answer. Square root of a negative 25, no answer. Square root of a negative 50, no answer. If I wanted the cube root, you remember, a cube root could still work. This was a square root. A cube root, for example, of a negative 8 was a negative 2 because negative 2 times itself 3 times does give you that negative answer. But as long as the root is an even number, a 2, square root or fourth root or sixth root, we can never take an even number root of a negative answer. Just does not exist. As I mentioned, the cube root of a negative 8 does work for us. So far, not too bad in terms of difficulty. Here's where we get quite a bit tougher now. We're going to be looking at fractional exponents. Okay? Well, notice if I take the cube root of x squared times the cube root of x squared times the cube root of x squared, we get the cube root of x to the 6th. That's because we were multiplying here. It would be comparable to how we reduced down some radicals in previous sets. For example, I might have had the square root of 8, which we might have said could be equal to the square root of 4 times the square root of 2. And then we would reduce the 4 down to a 2 radical 2. But I'm more concerned right now about this step right here. If I'm multiplying the radicals, I can multiply the arguments. So here I'm multiplying, which means the arguments x squared could be multiplied just like 4 times 2 to get 8. Well, when I multiply x squared times x squared times x squared, I get x to the 6, which has a cube root. The cube root is x squared, because if you take x squared times x squared times x squared, you get x to the 6. Keep that in the back of your mind now for just a little bit. Now, think about this once. If I have x to some unknown power times itself, it means the same power, times itself again, and I get x squared. What must that exponent be? What exponent plus itself gives you 2? Well, we would find that by taking the 2 and we would divide it by 3. Notice x to the 2/3 times x to the 2/3 times x to the 2/3 would give us 2/3 plus 2/3 plus 2/3, which would be 6/3 or squared. I've shown that right here. Those question marks have to be 2/3. When you add them up, you would have 6/3 or 2. Now go back up here. These 3 multiplied together gave you x squared. But also if I have x to the 2/3, x to the 2/3, x to the 2/3, I get the same x squared that I had up here. That's the basis for the logic of why we define the following things. We're saying here at this point, this radical, the cube root of x squared, must be the same as this expression, x to the 2/3 power. That gives us a basis for how we're going to define a rational fractional exponent. Okay, so that's the reason for that. We're saying that x to the 2/3 must equal that expression up there. That leads us to this definition. This is not easy the first time. X to this fractional power, a over c, can be written as the c-th root of x raised to the a, or I can take the a and move it outside like I did there. Copy this down. If you have to pause this lecture to copy it down, go ahead and do so. This is going to be a key for us, a key block, key building block for us here today. It's important that we can go from this expression, which we say is a fractional exponent, to this expression, which is a radical form. So this is radical form, fractional exponent. We should be able to go back and forth freely. For example, this one, the denominator of my 8 to the 2/3, the denominator is the type of root. So this becomes the cube root of 8 squared. Or if I want, I can take that 2 and move it out, like this a got moved outside. So I could change this to the cube root of 8 squared. I hope that you see I'm using that same definition of that fractional exponent. Well, the cube root of 8 we know is 2 because 2 times 2 times 2 gives you 8. So cube root of 8 is 2 raised to the second power gives me 4 for my answer. So 8 to the 2/3, I'll put it over here, 8 to the 2/3 power has to be equal to 4 using that definition. Similarly, we're going to use the same thing here. This time my denominator is 2, which means the square root. So I can change this to the square root. I really wouldn't have to write the 2 there. The square root of 16 cubed. I can put the cube on the outside. So I have the square root of 16 quantity cubed. The square root of 16 is 4. So I have 4 cubed. And that will give me then 4 times 4 times 4, which is 64. That means this 16 to the 3/2 had to be equal to 64. This process we need to be able to do with a lot of different expressions, which we're going to here today. Try this one on your own. I'll give you about 30 seconds and then I'll follow you up. Your final answer should have been 8 in this case. Again, we've been picking numbers that have integers for their roots. If you don't have that available to you, you may want to try your calculator. For example, this problem right here could have been written as 16. 3/4 is a fraction whose decimal is equivalent to 0.75. Well, if I go on my calculator here, I'm going to punch 16. I'm going to punch my caret button, which is, of course, an exponent. And I'm going to go 0.75. That's for this exponent. And I should get, as the calculator showed me, 8. Let's try the 8 to the 2/3 once. 8 exponent, 2/3 is 0.6 repeating. Notice that I get an answer here that is 3.99999. It didn't give me exactly the 4. It's because I couldn't get the exact value of that fraction right there. Let's just try something once. Let's go back to that and go 8. Raise it to the power. Let's put it in parentheses. 2 divided by 3. Now notice it gave me exactly 4. Exactly 4. So you should be able to do that on your calculator, but they would like you in many cases where the numbers are fairly small to be able to do it in your head. I will accept either method. You can use your calculator if you want. This one, I'd like you to notice that negative is not raised to the power. So this is very much like a negative. Now I have 16 to the 3/4 power. We just found 16 to the 3/4 to be 8. So because of that negative, it would give me a -8 for my answer. This one also has the negative out front. So it's really 8 to the 2/3, the negative out front. We found what's in parentheses, 8 to the 2/3 to be 4. So this would be a -4. Notice how that's different than this one. This one, the negative is raised to the power. So technically this one is the cube root of a -8 raised to the second power. Or I could have that written as the cube root of 8, negative 8 squared. The cube root of a negative 8 is a negative 2 squared would happen to give me the same answer 4. This one happened to be the same as what it was up there. Sometimes they will come out that way, other times not. I'm going to give you a few minutes to try each one of those, and then I'll come back and do them as well. But go ahead and try them on your own. This last one is a little bit more challenging, I think, mainly because it's a negative exponent. You might recall that a negative exponent could be written as a positive exponent if you put it in the denominator. We're going to do that here. We're going to take this entire expression, which was raised to a negative power, move the entire expression down to switch the power. In other words, this would become 1 over, just like 1 over this setting. I have 125, but now the power is to the 2/3. Well, we found 125 to the 2/3 to be 25, so this becomes 1 over 25. So if you have that negative fractional exponent, move it down into the denominator to make it into a positive. Some more examples that I would like you to try. Again, I'm going to give you a chance to try these on your own, and I'll write them out in a moment. See if you can stay ahead of me. this particular sheet is just practice going from radical form to exponential form. I want us to be able to go back and forth very, very comfortably. And what I'm really asking us to do is this. I'm asking us to go from this expression to this one or the other way around, back and forth. You saw this definition earlier here today. So let's do these. We'll go kind of fast. 7 to the 1/2 power, it's going to be the square root of 7. 4 to the 4/3, it's going to be the cube root of 4. That's the argument raised to this numerator power, which was 4. This one is the cube root of 2 raised to the power 5. This one is going to be the cube root of 7 raised to the power 4. This one would be the square root of 6 raised to the power 3. This would just be the 6th root of 2. I can go further now if I want on my calculator. For example, I can get this to come on, there we are. Square root of 7 would be 7, here's my exponent, to the 0.5. That's 1/2. And I end up with some decimal value, 2.646. I'm going to round it off to 3 places. The next one, I have the cube root of 4. So if I have the cube root of 4, I'm going to go 4 exponent 1 divided by 3. That gives me the cube root of 4. And then I'm going to raise it exponent to the 4th power. And I'll get 6.34. Technically, I should have gone up to 50 there. I didn't round that off. So I'll carry that one more place. This one, cube root of 2 raised to the 5th. So 2 cube root, this would be 1 divided by 3, parentheses. There's the cube root of 6, cube root of 2. And now I got to raise that to the 5th power. And I get 3.175. Cube root of 7. So I have 7. Cube root would be raise it to the power 1/3. That's where my 1 divided by 3 is. Cube root of 7 is 1.9129 raised to the 4th power, caret 4, gives me 13.391. And I hopefully could do that with the rest of those as well. This one, we're simply asked to write it in exponential form. This is a square root. So this would be 10. The denominator is a type of root. It's a square root. The numerator is that power. So that would be 10 to the 3/2. This is a 6th root. So it's going to be 2 to the 1/6 power. This one is a square root of 2. I apologize, I did that wrong. It's a 4th root. So my denominator is 4, my numerator is 5. This one would be the 5 raised to the 4/5 power. 2 raised to the 1/3 power. 10 raised to the 1/6 power. This one I'm expected to go like I did up here, take these exponents and put them into the radical form. This one I have a negative, so I would first move everything to the denominator. It would be 5x raised to the 5/4 power. That would be 1 over the 4th root of 5x raised to the 5th power. This one, it would have been 1 over the whole quantity in the denominator. Now I make it a positive exponent. That would be then 1 over the square root of 5x. And again, hopefully not that challenging for you to get through. This would be the square root of 10n raised to the 3rd power. This would be the 5th root of a raised to the 6th power. And again, we should be able to go back and forth as well as evaluate any of these on our calculator. Obviously, the ones with variables like these could not be evaluated on your calculator. One final example. A mammal's surface area can be calculated by using the equation S equals Km to the 2/3. Notice I have a fractional exponent. Where S is the surface area in square meters, K is that constant of variation. That's like what we just got done doing a few lessons ago. That's in this case a direct variation. So this would be S varies directly as the cube root of m squared is what that would really stand for. So we have to go ahead and find our constant of variation. Or actually, they gave it to us here. And they're telling us our m value is this quantity. They want us to find the surface area, S. That's my formula. It came right out of the problem. I'm going to plug in my K, which was 9.75. I plug in my m, which is 3.4 times 10 to the 3rd. This is a coefficient. This was raised to the 2/3 power. And 10, 3 times 2/3 would cancel, and I would just get 10 squared. 3.4 to the 2/3, I would have got on my calculator to be 2.261. 10 squared is 100. And now I simply have to multiply them all out. And of course, my answer is in square centimeters, which is what the problem told us it would be. Just an example of a word problem that has a fractional exponent. That's all we have for today. Signing again 8.3 this Friday, due next Wednesday, April 8. Have a good weekend.